Hello and welcome. In this video, we will create a simple car controller in Unity. We are going to use wheel colliders and new input system. I will try to make this tutorial as simple as possible. Basically, the kind of tutorial that I wanted to have when I was first time doing this. So let's start. First, let's set up a few things that we are going to need. Obviously, we are going to need some surface where this vehicle is going to drive on. I prepared a simple plane named ground. It's important that a plane has a rigid body and some kind of collider. In this case, I have a box collider. Important thing, since we are going to use new input system for this tutorial, we need to be sure that new input system is selected. We can check that in project settings, section player, and check input system new. And of course, we need a 3D model of a vehicle. I have prepared low poly taxi model. Just drag and drop your FBX into your project folder. What is important, that 3D model has all wheel meshes separated, like in this example. Drag our model to the scene. One more important thing is orientation of our 3D model. We check that orientation is proper with these arrows. Blue arrow should point forward and the red arrow should point to the right. What is wrong with this model? There are no colors. Usually FBX comes with already prepared textures. Drag and drop those textures into your project and color is here. Just a note that this and a lot of other models you can find on my itch.io page. A link is in description of this video. Most of them are free to download and use. Orientation is proper, all wheels are separated, and there are color palettes with every vehicle or object. Let's go back to our tutorial. Unpack completely our prefab and let's add some physics. First, add rigid body to our model. Set up the mass, let's say 1000. Then some colliders. I will do just a simple box collider. Now let's see what we have. Press play. What is happening? Our wheels are falling through the ground. That means we have to add some physics to the wheels. I will make 4 empty objects, one for each wheel. Those objects will contain wheel colliders. Now we need to position those objects. What I do, I simply copy position of every wheel mesh and paste it to its wheel collider, to its object that will contain wheel collider. In the end, we will have 4 separated wheel meshes and 4 separated objects that will contain wheel colliders. This is how I like to add wheel colliders. I just select all 4 objects, add component, wheel collider. I like to set suspension distance to 0 so I can properly adjust radius of wheel colliders. And later we can play with suspension distance and other settings. Hit play. And our wheels are not falling through the ground anymore. What we are noticing right now, this car is not moving anywhere. As we said, in this example we are going to use new input system. To start with that, we create new input action. Enter or double click, add action map, add action, first for movement, action type value, control type, vector2, delete original binding and add hours, select add up, down, left, right composite from the menu, double click, and for every direction add control. For up, which will be our forward direction, I will use W, for down I will use S, and so on and so on, like usual. Let's add one action for braking. In binding, we select our control. Very important after all of this to save this asset. And now the code. Let's add one script to the project. Create mono behavior script. Make some name. And start coding. I will go quickly through the script, try to explain the code as simple as possible. If there are any questions, please ask in the comments and I will try to explain further. This is our script. Let's delete update loop and start procedure. We are not going to use those. First, references to our wheel meshes and wheel colliders. Actually, we are referencing transform component of our wheel meshes, not the exact object. Let's add some variables which can be adjusted in inspector. Motor force, brake force and steering angle. And variables for handling user input. Float for throttle and steering and boolean for braking. Now procedures for handling user input. As we said, we are going to use new input system. This procedure, which I named onMove, will be in charge for handling direction and steering. It actually handles input that we already defined in our previous steps in input action. As we said, W for forward, S for backward, and A and D for steering. In simple terms, information that we are going to get from the user will be type of vector2, where X component of that vector will be handled as steering, and Y component will be handled as throttle. In more simple terms, when user presses A, X component of this vector2 will be -1. When user presses D, X component will be 1. Similar, when user presses W, Y component will be 1. And when user presses S, Y component will be -1. One more procedure, now the one for braking. We previously defined this input action as a button, and for that button we were using space. This procedure is a little bit more simple. Our boolean is braking is going to be true when space is pressed by user, and is going to be false when space is not pressed. Let's make the main loop. Since we are working with physics in this project, instead of update loop, we are going to use fixed update. Every frame, we will apply torque to the wheels, apply steering and brakes, and also update position and rotation of wheel meshes according to wheel colliders. And now let's make those procedures. In apply torque procedure, I will set torque only to the back wheels by setting motor torque value of wheel colliders. That value is 0, -1 or 1 depending of user input times already defined motor force. We do that for both back wheels, and that's all about the torque. Apply steering. Obviously, we will apply steering only to front wheels by setting steering angle value of wheel colliders. Similar like in previous procedure, that value is user input times already defined steer angle. Done. Now brakes. I'm defining a local variable, brake. Value of this variable depends on boolean is braking, so it will be 0 in case of is braking is false, and brake force that we already defined in case of is braking variable is 1. And then set brake torque value of all wheel colliders to the value of our local variable brake. Last thing that we need to do is to adjust position and rotation of wheel meshes according to the wheel colliders, as we said. Let's make a procedure that will do that. Before that, I will make a procedure which will be in charge of updating one wheel mesh. Parameters of this procedure will be wheel collider and transform component of game object that contains wheel mesh. Two local variables for storing position and rotation of wheel collider. Then get this information from wheel collider and store it into this two local variables and just set position and rotation of wheel mesh according to those values. Back to the previous procedure. Here we will call procedure that we just made for every wheel mesh. Control S to save our script. And let's see what we have now. Next step, add the script to our vehicle. We can do that simply by dragging script to the object and then drag wheel meshes and wheel colliders to respective fields in the script. Okay, we are almost done. One more thing, add player input component to the vehicle. Let's set up that component. Drag input action that we already prepared to the field input action. Set behavior of player input to invoke Unity event. And then set up the event. Quickly go to some other object in hierarchy, so our new action will appear in events. Click on plus to add new action for movement and braking. Drag our script component to these fields and select procedures on move and on brake from the script. So it looks like everything is here. Let's check what we did. Hit play. Steering works. Going backward works. Going forward works. And let's try all together. So that's it. We have functional vehicle. Now we can play with the settings, steering angle and motor force and brake force. We can make our vehicle to turn sharper, to move faster, slower, to brake harder. And we can also play with wheel collider properties. Let's change suspension distance to comically high value. Something is wrong. One of the wheel meshes doesn't follow wheel collider position. Let's check the script. So, there is a mistake. I am not updating back left wheel mesh at all. I am updating back right wheel mesh twice. Let's try now. Okay, now all wheels look good. And in flips. Okay, so the point is we can play with these settings of wheel colliders and we can get our vehicle behave differently. And that would be all for this tutorial. I hope that I helped. Thanks for watching.